So today we are going to talk about the unit circle again. But we're going to talk about finding sine, cosine, and tangent of an angle from the unit circle. Okay? So we're going to learn how to find these things without a calculator, because everything we need to find sine of 150 degrees, you could use a calculator, but we're not going to. We're going to actually use our circle. And the reason we want to use our circle, because there's some answers on the circle that are going to be hard to find. Okay? Now, before we start, we've got to make sure that we have our unit circle, that we have all of our degrees and all of our radians. Okay? So our degrees are in red, 30, 45, 60, 90. These are all our degrees. And then the ones with the pi's, those are our radians. They're both angles. They're both angles. One is an angle in terms of radians, one's an angle in terms of degrees. However, they're both angles and they're both in the same spot, which makes sense. A 30-degree angle, right, that much angle, is the same as a pi 6 angle, okay? Now, what you need to write on top of your circle is this. Cosine theta equals x. Sine theta, please write this down. Sine theta equals y, please write this down. And tangent theta equals y over x. Now, of course, Hayden, you already got it, because I already have it there for you, don't I? Yep, because you have my circle, don't you?
I'm super smart.
You are super smart, okay? You need that, okay? That's super important, okay? This is what we're going to do today, okay? Okay? So, x, y, y over x. Well, it turns out that all along this circle, am I going too fast? All around this circle, at every little spot, are points. This is a point, and every point has an x and a y. Every point, this is a point, every point has an x and a y. Every point has an x and a y. Every point has an x and a y, and all the way around, okay? So we're going to be able to do right triangle trig without a calculator by using our circle. So cosine is the x value. So the cosines are all these x values at each angle. The sine answers are all the y values all around the circle, okay? Now we added something second period that we're going to add in here also. We're going to wait to add these, okay? First, let's try and do the first equation, okay? So sine of theta is y over r, but for us, the r is 1, so it's really sine of theta is equal just to the y, right? Because r is 1. That's why I didn't write the r down in this, because the radius of the circle is 1, okay? Cosines x over r, tangents y over x, okay? Now there's a few other I want to add. I want you to write this, CSC, that's cosecant of theta is equal to the r over the y. It's just the upside down. Now, cosecant is spelled like this. Cosecant. No, it's not on your calculator, okay? The inverse of cosine is secant, and that's going to be r over x. So it's spelled like this, secant. Okay, we'll call it secant. It's not sec, okay? Cotangent is of an angle is the x over the y, okay? And that's cotangent. Alright? So I've got its reciprocal. The opposite sine is cosecant. Instead of y over r, it's just r over y. The reciprocal of cosine is secant. Instead of x over r, it's just r over x. It's just the reciprocal. And the opposite of tangent is cotangent. Instead of y over x, it's just x over y, okay? Alright, now let's see how easy this stuff is, okay? Again, I'm going to write up here the three that I'm going to use mostly. The three I'm going to use is this. All right, sine theta is the y, cosine theta is the x, and the tangent of theta is the y over the x. Okay, those are the ones I'm going to use because I'm on the unit circle and the radius is 1. I don't care about the r is 1. So I'm just going to write it without the r because the r is 1, okay? Now, so let's do it. Sine of 150 degrees. Yes, you can use your calculator, but I'm going to use my circle. There's times you're going to want to use your circle, okay? So I go to my circle. 150 degrees. Here it is. I'm looking for the sine, right? For the sine. Here's a point, xy, right? The answer is 1/2. Sine of 150 degrees is 1/2. Now, if you don't believe me, yeah, your calculator will actually do it. Just plug it. Go sine 150, and I get, oh, I'm in the wrong mode. I'm definitely in the wrong mode. I knew I was in the wrong mode. Degree, enter, clear. So I get 0.5. I already knew that from the circle, okay? So you're thinking, why would I even bother with this stupid circle when I can use my calculator, right? Well, let me keep going, okay? Cosine 2 pi thirds. How do I do that? Well, let's go, yes. Yes. Here's 2 pi thirds, or 120. If I'm doing cosine, I want the x value. So here's my point, right? Oh, sorry, here's my point. It's off by a little bit. Here's my point. I want the x value, so it's negative 1/2. It's negative 1/2. Okay? Tangent of 300. Now, wait a minute. Tangent is my... Am I going too fast?
I'm sorry. Why is it 1/2? I know you just said it.
Great. Let's go to 2 pi thirds. So we're doing cosine, right? Here's 2 pi thirds. What's the x value of the point? Yeah, it's shifted over.
Okay,
Yeah,
okay,
yeah. That's why you might want to make your own circle, because your own circle is going to be better than mine, right? Mine's a little sloppy. Right, Rosa? Mine's a little sloppy. I have one really good one, and then it disappeared.
Oh, that one.
Yeah, I had one really nice one. Okay, tangent of 300. So I go to 300 degrees. 300 degrees is right here. Okay, with me? Tangent is the y over the x. So I'm going to go negative. I want the y over there, so I'm going to go negative square root of 3 over 2 divided by 1/2. I'm going to go negative square root of 3 over 2 divided by 1/2. Oh, that's a pretty awful answer, right? The 2's will cancel, and I'll get negative square root of 3. Now you can say, well, gosh, I'll just use my calculator, right? Well, okay, let's just use our calculator. Tangent of 300. That's a different answer. That's a different answer. So tangent of 300 didn't work on my calculator, did it? No. This is the decimal equivalent of this. Negative square root of 3 is about 1.73, blah, blah, blah. I want this answer. If you put that answer down, I'll mark it wrong. Because this is not an exact answer. That's not an exact answer. Plus, it forces you to use your circle, doesn't it? Now, this is kind of a pain, right? This divided by this, that's kind of a pain, right? So lucky for you, Rosa, in my pre-calc class, put all the tangent values on the circle. In fact, we did all of this dividing. We did this divided by this divided by this divided by this. We did all around the circle, and we put them up here in pink. So the tangent answers are the ones up here in pink. So let's add those to your circle real quick. So those are your tangent answers, right? So let's put them on. Let's put them. Okay. So let's start here at 0. Okay. And if you need a different colored pen, that's fine. Different colored pencil. So I've got colored pencils in the back if you want to color pencils. But we're going to add in all of the tangent values. Okay. So are they on yours because you borrowed mine?
Oh, yeah.
Right. You already have them. Hayden, you already have them, right?
I'm just going to highlight.
Yeah. So tangent of 0 is 0. Tangent of 30 degrees is the square root of 3 over 3, okay? Tangent of 45 is 1. Tangent of 60 is square root of 3. Tangent 90 is undefined because it's the 1 divided by 0. You can't divide by 0. So the tangent of 90 is undefined. How's that? Can you see them? And then I'll slide it back up when we keep going around, okay? That's an empty set. It's undefined because it's 1 divided by 0. And you can't divide by 0. So it's really undefined, okay? 120 degrees is square root of 3, negative square root of 3. 135 degrees, the tangent value is negative 1. Negative 1, yeah. And luckily we have it up there too. That's a lot neater than what's here. 150 degrees is a negative square root of 3 over 3. Tangent of pi, or 180, is 0. Okay, you guys writing this down? Oh, you don't need to. You got mine.
It's already on.
You got mine. Yeah. Okay. 210 is square root of 3 over 3. 225 is 1. 240 degrees is the square root of 3. 270 degrees is undefined. 300 degrees is negative square root of 3. 315 degrees is negative 1. 330 degrees is negative square root of 3 over 3. Okay, so go ahead and put those down. And if you can't read them that well, they are also up there, okay? Yeah, I want to go back up, Will. How's that? Okay, they're all up there. And of course, they're on the board also, right? Huh? They are mirrored. They are mirrored. And you're going to find out why. Because if cosine is the x, then you've got an x value this way and an x value there, right? Yeah. Plus, remember when we drew the triangles? Right? And the triangles mirror this way too. Yeah. Symmetry.
No,
the unit circle. Oh, the tangent ones. Yeah. What are the?
I know it's tangent, but like, is that what it is?
This is just tangent for now. Yeah, yeah. But you know, it's not a bad question. I was wondering how technical of a question you were actually asking. Okay, everybody have it? So let's go back to our notes. Okay. Okay, sine of negative pi force. Well, okay, so negative pi force. It's not on my circle. Negative pi force is not. But think about a rotation. Watching. Pi force rotates up to here. A negative pi force would rotate down, wouldn't it? So rotate. If it's a negative angle, it rotates backwards. So negative pi force would be right here. So pi force rotates up this way. It's an angle of rotation. Rotate up here. A negative pi force would rotate the same amount of rotation, but backwards. So I'm at this spot right here. What I need is the sine. So here's where the answer is found. The sine is the y value. So it's going to be negative square root of 2 over 2. Let me do it again. Okay. So I want to find sine of negative pi force, right? This is... Okay. Great question. So I start at 0, and regular pi force is this much rotation. Think about 45 degrees. I rotate 45 degrees this way.
Why don't you start on the other side?
Always start at 0. Always start at 0.
So that's 0.
That's 0. Yeah, that's 0. So if I rotate up 45, what would negative 45 be? Rotate down. This is where I find my answer. Since it's sine, I want the y. So I get negative square root of 2 over 2. 45 degrees. Or 1, 2, 1, 2. Alright, let me keep going. Cosine of 90. Okay, so where's negative 90? Where's negative 90? It's right here. How come? Well, you're the same thing, Juan. If I went from 0 to 90, I'd rotate that much. 1/4 the circle, right? But negative 90 would be going the opposite direction. See? So I'm down here, and then what am I looking for? Sine or cosine? Cosine. Cosine is the x value. What's the answer? What's the x value of the point? X, y? 0, right? 0. Okay. Tangent of 90. So let's go to 90 degrees. Here it is. There's 90. Tangent, those are the ones on the outside, right? It's undefined. It's undefined. Well, that means undefined. So we're going to write undefined. Okay. Sure. Yeah. Okay. Sine of pi. So let's go to the angle pi. Okay, Garrett? Where's pi? Right there. Okay, sine is the y value of the coordinate. So I've got x, y, x, y. What's my answer? It's the y value. It's got to be 0 because sine is the y. So it's just 0. Yeah, James.
Why is 90 undefined but negative 90 isn't?
It is, negative 90 is undefined. For tangent. For tangent.
Oh, for tangent.
For tangent, right? Okay. Cosine of 450. Well, 450 is not on my circle. 450 is... Yes. Good job, Arthur. We keep going around. In fact, if I went 360 degrees plus another 90, right? Right? Wouldn't you agree? 360 plus another 90. So I'm going to do what Arthur said. I'm going to go 360, and then I'm going to go 90 more, so I'm right here. This is where I find my answer. I'm looking for the cosine, which is the x value, which is 0. X value is 0, right? Okay, now, Juan, you ready? 2 pi thirds. Here it is. Right? And if you want to think of it in terms of degrees, same thing. So think of 120 degrees. Same angle, right? But I want to go negative 120. So don't go this way. I'm going to go rotate to here.
So go back down.
Go back down. So I go back to 240, really, right? So this is where I find my answers right here. But I'm looking for the tangent. So it's got to be square root of 3. Okay. Okay, now, example 10. You need a new formula, okay? So, before I give you your formulas, we got to look at our circle again, okay? Example 10. Huh? Oh, one more time. Okay, I'll do number 9 again. Okay, here's 2 pi thirds, or 120 degrees. So, to rotate positively, I would rotate to here. But I have a negative. So, on negative angles, you rotate the opposite direction. So let's rotate the same amount, put me right to there. Alright? That's the same rotation. My tangent value is right there. Okay. Alright, now, you guys ready for number 10? You're going to need a new formula. So arc length. So arc length. Yeah, arc length. Let's write these down. You have theta over 180 times pi is arc length, okay? Or arc length is theta times the radius. You got 2 formulas. You know why you have 2 formulas? You have 2 different angles. You have angles in radians and you have angles in degrees, right? So which one is which? If your angle is in degrees, use this formula. Makes sense because that's 180 degrees, right? If your angle is in radians, use this one. This looks like a pretty simple little formula, doesn't it? That's why we learn radians, because radians are equal to their arc length. Radians are equal to their arc length. This arc length is pi 6. That's the length of it. This arc length is pi 4. That's the length of it. So now we have an angle that corresponds to its arc length, which makes the formula so easy, right? If the radius is 1, it's just the angle. So you can find the arc length. If it's in radians, it's just the angle times the arc length, times the radius. That's it. Okay, so this one, example 10. Which of the 2 formulas am I going to use? First or second? Right, because it's 50 degrees. So to do this one, we're going to go, okay, I'm just going to go 50 over 180 times pi, and I'm going to use my calculator to get an answer. So if I just go 50 times pi divided by 180, I can answer about 0.87. Oh, I forgot the radius, didn't I? Oh, my bad. I'm tired. Put an R here for the radius. I knew something was wrong. Times 5. Times 5. Yeah, times 5. The answer is 4.36. I thought that was kind of small. Got the radius. Okay, arc length. Theta over 180 pi r. Arc length is just theta r. Okay, easy. Okay, let's go ahead and stop the record.